New subject. New subject. We're going to do a PI controller for the next 2 weeks. Proportional plus an integral term. You want to see what that looks like in the time domain?
Yes.
Or the LaPlace domain?
That one's in.
Alright, I'll show you what it looks like in the time domain. Is this familiar to you? Please say yes.
Yes.
Yes, Dr. Henry.
Thank you, Jerry. Now, in this book, they use a little bit different lingo, but it means the same thing. They use a capital T for a tau. That's okay. It's just a different language. It's the same thing. And they use a little L. They use an L for T0, and that's okay. And the reason I know that is because I look on the preceding page, and there's a graph where they tell you what L and T are. L is the dead time, and T is the time constant using a method that is the original method used by Ziegler-Nichols. That's not the one where we go out and go 63%. This is a different way of getting the time constant. Original way that Ziegler-Nichols did. So, this is wise that they did that, because then they gave you the Ziegler-Nichols formulas for tuning a tuning rule based on step response of the plant. So if you did a step response experiment, you get these parameters, K, L, and T, or K, T naught, and tau. You've been getting those. If you have those, then this gives you formulas for a proportional controller that the controller gain, by the way, he uses K subscript P, where I use K subscript C. This is the controller gain. This is the integral time constant of the controller. These are controller parameters in this table. And for proportional, this is a proportional only controller, which we've been doing for 2 or 3 weeks. The proportional gain, T over L. T is what now? That's time constant over dead time. Let me show you another way of looking at that. Let's go back here. Let's look at today, this week, starting 5 p.m. today, we're going to design a PI controller for your system. Each of you is going to do that. Everybody in your team is going to do that, starting at 5 today, and by noon Monday, you'll give me your results on Blackboard. And what that means is choose a KC and a tau I to give the response that you want for your system. In this assignment, use one of the formulas for tau sub I and draw a root locus. So this week, you're going to draw a root locus again. Wouldn't it be nice if you all knew how to do that, say, in MATLAB? Or had an Excel spreadsheet that did it for you.
That would be nice.
So that's what you're going to do. Now, formulas for tau sub I and Smith and Caribbean, let me show you what they are. I've got them out here. T0 over tau. Let me remember these things. Proportional gain is time constant over it. T over L in Ogata language is time constant over dead time. Philip's agreeing with me. Anybody else agree with me? Jerry agrees. David agrees. Now, look at this. Ignore this for the time being. What is this?
The opposite?
What'd you say?
The opposite of that?
It looks like it, doesn't it?
Except it's inverted.
Except it has a -1 on it for some idiotic reason.
The same.
So it's the same thing.
It's just more confusing.
I'm not sure why these formulas have a K in the denominator and the others don't. I suggest you use this one. What should I do? Somebody send me an email and say, Dr. Henry, why does Ogata not have a K in the denominator? And I'll see if I can figure it out and get back to you. Now, the integral time, that's tau sub I in the problem. There isn't one for the proportional controller. For the PI controller, look at this, 3.33 times the dead time. This is the formula that Ziegler and Nichols dreamed up. What are you thinking, Jerry? How many significant figures? Let me say something else. From now on, starting today, any controller parameter, gain, controller gain, KC or KP, or dead time, no more than one significant figure ever. Does that give you attention? Yes, sir.
For the model of proportional control, you said
Not a whole lot. Used to for the model of the proportional control. But did you notice that some of these experimental results that were presented today? By the way, Glenn, was it yours that had the infinity controller game? That's what my oven has. You remember the first week or two you did an oven observation?
Yes.
My oven has an infinite controller game. Stays right on there. Very fun. So infinite controller gain's okay. Sometimes. So are you with me in one significant thing? If any of your teammates are not here right now, will you communicate in real clear language that your customer doesn't want to see picky, small variations in controller? This is going to stress you out.
D, thanks, Dr. Henry.
So, take an aspirin or something like that, say, oh, okay, I gotta get it down to one significant digit. All right, so let's look at these other formulas in the book. Look at that. That's about the same as the other one, only this is one significant figure, right? Yeah, it's the reciprocal of 0.3. The other one was 3.33, if I remember right. Now, here is 9/10 as big as the controller gain was last time. Smaller controller gain, but there's an integral sign to it. Now, there's another set of formulas. Would you like to see them?
Yes.
Well, they're on the very next page. By the way, this is called first method. Everybody say first.
First.
Method.
Method.
Caroline, did you say that real loud?
What is it?
What's the first? You said first real loud, didn't you?
No, I said method real loud.
Who said first real loud? Somebody.
Somebody up there.
Who?
It was Ronnie.
It was. What do you suppose the other method's called?
The second method.
Now, why they don't call it the last method, I don't have any idea, because there are only two that they're talking about.
For the future, maybe.
Yeah,
They're leaving room for
There
expansion.
might be a third method come along.
You never know, we might find one.
That's all right.
That's all sick.
This is based on the critical gain and the critical period. These things you can get easily from what?
Root locus.
Easier than root locus. Relay response. One experiment on relay response will give you the critical period and the critical gain. One experiment will give you that. If you don't have a good idea about the critical gain and the critical period for your system, I would encourage you, particularly if it's a new system for you, like you've been jerked off into something that takes forever, and you can do something now that just takes 2 seconds. Maybe a relay response experiment would be a useful thing to do. In which case, this table gives you what the proportional controller gain ought to be, the proportional term, the gain, and the time constant. By the way, have you noticed that we're not talking about this column at all?
Yes, Doctor.
Did you notice I left that out? Got any idea why?
Because we're not talking about, we don't have the last P and an I.
What'd you say?
We just have a P and an I. No differential part.
Why don't we do D?
Because we don't have two
Too
more.
many significant.
Because we don't have 2 more weeks. There's one answer. If you'd like to come back for 2 more weeks, we can add in the differential term. What do you think, Stephanie?
I'm good on that.
Huh?
I'm good on that.
She's good on that. There's another reason. In my experience, this never helps you. The reason being, the derivative term in a controller means that it looks at the derivative of the output and adjusts the controller gain based on